Yeah, so what did you guys put as the definition for the sampling distribution?
Well, that's what I kept trying to like. I couldn't even like come up with a definition. Like I was like, because what kind of threw me was where it says like in the reading. Well, I ended up looking at the answer key because I was like, I don't know, and it says the set of all possible sample means from a population. What does that mean? Like I couldn't really
Yeah,
get that. And what
I
it would
find
mean.
it like I couldn't figure out if it was saying it's like the mean of the mean, like all the different means of the
Because
set of data.
that's the simplest thing that made sense to me, but it doesn't seem like that's it.
I think what they mean is that, let's say we're working together on a project and each one of us gathers 100 surveys, let's say, of something. So we all have 100. We each do one section of 100, and together that's our sampling distribution. Even though each have a separate one, that's how I kind of understood it. And they're talking about, maybe tens of hundreds or hundreds of hundreds. So we do those little things where it drops down, that's where we get our distribution. It's on that little graph. That's just what I understood. I could be completely wrong.
Yeah, because I guess like if you think about like if you, I think that sounds really good because like I was just looking at the book here, and the way it looks like it's kind of explaining it is like in the real world, like we only see our sample mean. So like if we went out and collected data, say like we had like 10 sets of data, like that's randomly chosen, like we can find the mean from that, but there's like another 10 people we could have randomly pulled data from, and like so like there's other possible means that there could be because we could have different data.
Mm-hmm. I agree.
Because like the mean that we get is just from the sample that we draw. So like if we drew a different sample, it's possible that there could be a different mean. But what it's saying is that in some cases we know that the mean would be the same even if we drew a different sample. If we know that like for instance when it talks about like the normal distribution, we know that the mean would be the same because the data is normally distributed. So it's the same, like evened out, like evenly spaced no matter what values we get, if that kind of makes sense.
And I think sorry, I'm echoing. If we draw from a group and our samples are not coming up normal, it might be that we didn't get a large enough group. That's kind of what I understood on a whole.
Yeah, because it said that, like one of the ways that, like, I think it was saying like one of the ways that the mean would be the same is if there's, if the population, if the sample size is large, like if it's drawn from a big sample, because that's like what the whole law of large numbers was like. Well, no, never mind, because that was just saying as the sample gets bigger, the standard deviation gets smaller. But.
Well. Am I only echoing on your side, or am I echoing with you guys?
It seems to be causing interference because, like, when you start talking, I start hearing words and then it gets like really jumbled.
I'm sorry.
But that came through just fine when you said, "I'm sorry."
Yeah.
That's so weird.
All
right. So, what do you think about number 1? Did that make sense?
Yeah, I think like talking through made it made a bit more sense just talking about it. I think like verbalizing it.
Mm-hmm. How do we feel with 2 and 3?
My brain is still like
trying to wrap around it.
Yeah.
Did you play with that little graph where you dropped little means?
Yeah, I pulled it up and I was kind of playing with it, but I didn't really.
So they were playing with it, dropping little means, and they were all over the place. You know what I mean? And the more that they did it, that was their sampling, and it just kind of filled up that space the more that they did.
No. Kind of takes a little bit to think about sometimes, I guess, just to kind of like. Is there anything in particular that you don't that is tripping you up on it?
Because I mean, I know what a sample mean is, but like, and then they're talking about like the distribution of sample means. But then like I don't really understand like why are we even looking at the distribution of sample means? Like where does it go from there? Like, okay, you know, like say our sample means like, you know, if if all of us, you know, like Susan was saying, like if we had, you know, we pulled some data out of, you know, the same population, but then our sample means were slightly different. Like, and I know I saw in the videos that like eventually with enough, you know, they start approaching, you know, what the population actually is. But until you get there, I don't really know why they would ask like, what's the sample distribution? Like sampling distribution, excuse me. The question itself almost doesn't make sense to me because, like, I get that, you know, every sample you take is not going to be 100% representative of the population. You know, I shouldn't say 100% representative, but it's not going to have the same mean necessarily as if you continue to expand your sample, you know, to include a really large sample. But I guess why do we care what the sampling distribution is?
We may not know yet. We may not know why we need to care. But if you again look at the word distribution, each sample drops in a different spot in that little chart.
Yeah.
So I know I'm probably oversimplifying it, but if it's dropped a certain spot on that chart here and here and here, well, each of those samples is being distributed. And that's when we take our multiple samples, that's how they're distributed. They're little blocks that are dropped kind of like Tetris. And I, like I said, I think I'm oversimplifying it, but that's kind of what I got out of it. That's all it means. It's simple. Our sample distribution along the mean line. Once we get enough data, it's going to look more like the norm. If we have just a few little means, it's going to make a funny little shape that doesn't quite look like the normal mean. The little bell shape. I don't know. Am I oversimplifying it, Todd? What do you think?
No, I mean, I think it's kind of, I think you're kind of right when you're saying like, we might not know yet because a lot of the concepts kind of like build on each other. But what I found is like, I think just like my personal opinion is that like knowing the definition, like, I don't know, I've just found like if you can like solve the problems, like, I don't know, for me sometimes like even when I don't know exactly what something is, I can still solve the problem and get the right answer. Like, because you just learn, because like all the questions that are asked on the preparation is not, there's just like a formula that you use to find it, where it's just like you do the same thing every time. So to me, I was just like, you know, like I understand it kind of, but I understand totally how to like do the questions that pertain to it. So to me, I just kind of focus on solving the problems that pertain to it rather than just like
the definition.
Yeah, but I mean that doesn't work for everybody. I understand that because it's important to understand the definition because it helps you understand what you're doing. But for me personally, I like just being able to do things just kind of like without having to think much about it. So to me, it's just like, oh yeah, there's a formula. I just plug those numbers into it and get the answer. I don't really question it too much. But I realize that that's not always the best route to take.
How are you doing with 2 and 3, guys?
Yeah, because on 2 and 3, like if the data is normally distributed, then the shape of the curve is normal, and then if the data is not normally distributed but the sample is large, it's still normal shape.
That's a weird.
Yeah, it's like the two times that it's the two ways that the mean can be approximately normally distributed is when the data is from a normal population or when the sample size is really big.
Yeah. And that made sense to me.
Yeah. And then on number 4, I just figured like the shape of the distribution of the sample means changes. Basically, like when the standard deviation goes down, it becomes more normally shaped. It's kind of what I thought. But I can't remember why.
Well, I'm just looking at the entropy and sample distribution. Yeah, more closely approaches a normal distribution, and the standard deviation decreases because you're getting such a, as what does it say that sample size
Because it's getting like closer together, right?
Yeah, because you're basically getting closer and closer to the population. And so, I mean, again, from what I understood, yeah, that would mean that it's just going to approach more and more that whatever its normal distribution is.
Mm-hmm.
So, number 6. What is bar X?
That's the symbol for mean, right?
Yeah. Mm-hmm.
The mean was the little u.
That
wrong there?
I thought that was like the. What did he say? That what? You mentioned that in the video, the first one.
Yeah.
Or maybe the bar X is it like the sample mean?
But the sample number, the sample.
Oh yes, yeah. So the bar X is the sample mean. Yeah.
Yeah, and in the U is the actual mean.
Okay, use the actual. That's the sample mean. Okay, that I didn't know. Thank you.
And so when is it normally distributed? Yeah, again, it's basically the same thing like in the other questions. If the data it's coming from is normally distributed to begin with, then its sample mean is going to be normally distributed. Or if the sample size is large enough.
Funny, some of these answers are so close to each other.
They're all kind of the same question almost.
But not.
Looking at it at different angles. Yeah.
Yeah.
I mean, my brain is still having trouble with sampling distribution, but there you go. Please cut out the squares. Oh, what?
Yeah, I just pulled 5 of the numbers off of there. I didn't bother cutting them out.
I did it. I was almost smack dab in the middle. It was kind of bizarre. I'm like, oh.
What number did you get for your mean?
I got 45,980.
See, mine was actually kind of on the low end. I had 42,760.
Wow.
But it's still in the shaded area section, so.
Yeah. Yeah, I think I was like 1 bar off being right in the middle. I'm like, okay, that's weird.
Nice.
Yeah.
It's kind of cool having them randomly pick a number.
third. Hmm. Oh, it's funny because D is like, hey, compare the means.
So Todd, yours was low.
Yeah, well, that's interesting how much further down it was than what you got, Susan.
I might have did it wrong. It's entirely possible.
What do you mean you did it wrong?
I don't know. Like, I mean, like they're going to be normal. Because it just depends. I just picked 5 of the numbers. I could have picked 5 of the lower ones, so the mean would have been smaller.
Aren't they distributed? Huh, I don't know. I think they're randomly distributed.
It doesn't say they're normally distributed, and like the the definitions were saying, basically, if your sample is small, which 5 out of 30, let's see, that's 1/6, right? So it's only like, I don't know if that'd be, quote unquote representative of whatever, this population actually is. And when you look down at the picture, yeah, it's, the normal distribution. So I'm guessing, and maybe this is what, maybe I'm starting to kind of figure out what sampling distribution is. Like, so basically over time, the more and more samples you take, it gets, like you were saying, Todd, that like if you average those, or you take the mean of those, then that's where you start approaching the population. Is that right?
I think.
So I think if we were to do like 5 times a piece and come up with 5 different numbers, and then we were to merge all 15 of our numbers, I think we would, and line them all up, I think we would be closer to the shape of the bell. Rather than right now, I just have a little arrow sticking in there.
Like I'm just, because I didn't do this part like you said, so I'm just doing it now and just kind of seeing what I get.
Yeah, like you just pick 5 random numbers and compute the mean. Because it says like there's 142,506 possible combinations of the 30 salaries that are drawn 5 at a time. So that's like there's that many different means that you could get. And that graph is like showing the distribution of like what means, what like the different combinations of means that you could get.
So I guess that means that yours is still in there.
Yeah, like
normal distribution. That makes sense.
Yeah, like my mine wasn't wrong. Like it wasn't abnormal. It was just one of the lower means that you could have gotten.
On the lower end, right? Okay.
Because like it's not smack dab in the middle. It's just because it's gonna pepper all around what the actual mean of all those numbers is. So like there's gonna be some that are lower than the mean of all of them. There's gonna be some that are higher, but the mean is gonna be right there. And
the mean of our mean.
Yeah.
Yeah. So I think you did hit it on the head, Todd. Like it's the mean of the means, like all together, that creates that distribution.
Yeah.
It's, I guess how you look at the whole picture of it being normally distributed.
Right.
So I think if it wasn't normally distributed, I mean, obviously you wouldn't have that shape, but it would also mean that I think it'd be less likely that you would, I guess, I don't know how to say that, but
Yeah, because then like if you go down to I think like if you understand how to do number 8, I think that's where like the bulk of the stuff comes from. Like when you look at that question, when it asks like what's the shape of the distribution of the sample means, like if you know that it's normally distributed because if you know the shape of the distribution will be normally distributed because that's what like those two things where it's going to be normal if the shape of the sampling distributions are normal, or if the, you know what I mean, like if you know how to identify when it's going to be normally distributed, like if it comes from a big population.
Right. Well, yeah. So in this case, even if they didn't have a big sample size, like what's the shape? You just say it's a normal distribution. So that,
because it says right in the question.
Yeah,
because it says right in the question the scores are normally distributed. So like if the question says they weren't normally distributed, but it says that the sample size is considered large, then you would know that it's still normally distributed. And then the mean of the sampling distributions, like C, the mean is going to be the exact same because it's normally distributed.
What is the mean of the sampling distribution of sample? What? There's too many sample words in there. What is the mean of the sampling distribution of sample mean scores for all such samples?
It's just the same as the mean. Well, you don't have to calculate anything for that one because it gives you the mean. So like because it's not, because like it says in the book that the mean of the sampling distributions is going to be the same as the actual mean. Like the bar U, I can't remember what it said, but like they're basically the same if it's normally distributed.
Okay.
I'm trying to find where it says that in the book.
I think they just wanted to throw sample in one question a bunch of times.
At least 3 times.
Yeah. Okay. Let's do that. Minimize. Okay. Save.
Because then like when it asks for the standard deviation of the distribution of sample means, like there's the formula to do that where you take the standard deviation that's given for the simple random sample and you take that divided by what is it? It's like the square root of the population. So for that one, for D, you just take the standard deviation, which is 113. You divide it by the square root of 10, which was the population that they took it from. It gives you the standard deviation of the distribution of samples.
Oh, okay. So let's see. 113 divided by 10. Okay. So C would still be the 529.
Yeah, because the mean. I'm still looking for. I know I read it somewhere in the book, but the means are the or no, it might have been in the video actually. But I just remember I saw it. I just remember I saw it somewhere that like when it's normally distributed, like the means are the same.
Okay, and so then on 8D, when you were talking about that, there's that formula where it's the standard deviation of the sample means is sigma, which is the standard deviation, divided by the square root of n, which is the sample number. So on that one, so you'd end up doing 113 divided by the square root of 10, right?
Mm-hmm. Yep. Exactly.
Why am I not getting the same answer as on the answer key? That's weird.
What's that?
So did you type in 113 divided by the square root of 10?
Uh-huh.
Did you close the, like, are you doing it on a calculator?
Yeah, I just did it on the calculator on my computer. And let's see.
I don't know, is it like a parentheses you have to close after like something? I don't know.
Oh, do I have to hit enter again? There we go. I guess I had to hit enter again because it gave me the square root of 10. I was like, that's not what I told you to do. Yeah, okay, 35.734. Okay. So that would be this, okay, basically saying how spread out the samples that we would take would be, right?
I guess. I mean, the way that I kind of understood it, like the standard deviation, yeah, it's basically how spread out those sample means are gonna, yeah.
Okay. Okay. And so then, okay, so I did my what number was that? 7A. And I actually got a little on the higher end. I got 51,660. It's still in there. I think, obviously it's going to be in there, but yeah, it's on the higher end.
Yeah, so isn't that really interesting? Like, I think that's kind of what we were supposed to see from that is like mine was on like the lower end, Susan's was in the middle, and yours was on the high end. So it kind of shows that like no matter which 5 you take, it's going to be somewhere within that spread.
Yeah. Okay. Well, yeah.
That's actually really kind of that's kind of freaky how that happened, actually. I guess it's really not freaky if you understand statistics. It's probably expected.
Which is what I'm working on.
Yeah, I mean, I was just like, I surprised me. I had no idea.
Well, I'm glad I did it with you guys because I probably would have been like, I got this wrong.
Yeah, like I actually have found that like I found these group meetings to actually be pretty helpful. Like being able to like talk about it actually helps me to work through it in my head. So I think it actually has been pretty helpful.
Okay. Well, I'm gonna like go through the reading again and then just kind of look at definitions and probably work the examples again. But I think I'm doing pretty good considering.
So do we want to take a stab at the group quiz now? I just opened it up and took a peek at it. It's not really that long.
Oh, is it scary?
Oh, nice.
It's only 12 questions, so it's like
only 12.
The shortest one so far, I think, isn't it?
Yeah, because I remember the one last time was like a beast.
It wasn't like 15 or 16 questions.
Yeah, something like that.
Jeez, it's
but these ones,
where I can't see it.
These ones don't really look that hard, though.
No.
Right.
No, I actually went through and I think I answered them, but I don't know if they're right. But I think we get to talk about it.
Sorry, guys. It's like a window this big. Oh, that's fine.
Your group quiz isn't loading?
Yeah, I just loaded it, but I had to reload it.
Oh, okay.
We're going to be using the probability applet. Oh.
I didn't have to use the applet. Like, I think it's just there if you need it, like if you need it.
Oh, did you already do the quiz?
I mean, I just like I went through and looked at the questions and just kind of like made mental notes, but like none of them were things that because we didn't use the applet on the preparation, so
Hmm.
there's no reason for us to need to use it now unless there's like one of the review questions, but it didn't look like there was.
Okay, so
But yeah, like I just opened it up like right before I mentioned like, oh yeah, let's do the group quiz now.
Taking a sample size of n equals 5. What is the shape of the distribution of means? Histogram. Wait, are you guys seeing a picture somewhere?
no.
Oh, okay. I was like, I'm not seeing anything.
So for this one, like it's just asking what the shape is, and I don't know if I'm pretty sure that just looking at that, like I don't think it would be normal because the sample size is kind of small and it doesn't say it was taken from a normal
Right.
distribution. It was right skewed. So I'm assuming that the histogram would be right skewed as well, right?
That's my guess, but I'm
I
not
feel
sure.
like they need more information in that question because I feel like
Yeah,
they should say like
because it doesn't tell you because 5 could
or
be
like or give an
for a certain
inconclusive
study.
option. Exactly,
Yeah.
right. I feel like there should be like an inconclusive option, but I think given the options skewed right is probably the best.
Yeah, because I don't see any reason why it would be left skewed, and it's only normal when the population is big or if the sample is normal. But
yeah, and see like question 4, sample size of 100.
but even though it's right skewed, wouldn't that be normal because the sample is bigger?
I mean, yeah, that's what I would say. But again, I feel like we need more information.
Yeah, like it doesn't elaborate a whole lot.
Okay. I guess we've got 2 attempts anyway, so
Yeah.
Okay, so now here, I think they're trying to kind of trick you because they threw in just normally distributed at the end, so it's going to be normal.
Yeah.
The sample size is small.
Yeah. I think that's right. And then, yeah, number 6, it almost seems like it says like, yeah, the sample size is big and it's normally distributed. So like, pretty sure that would be normally distributed as well, right?
Yeah.
That's what I put.
Okay, so this is choose all correct responses on number 7. One means normally see data I draw population. That is yes. So the first one I would say is correct.
What order do you have them in? Is it data?
Oh, whoops! I forgot. Yeah, they can have in different orders.
Yeah. So my first one says data are drawn from a population that is normally distributed and the sample size is small.
That's what I have.
That's correct. And then the next one I marked is data is drawn from a population that is normally distributed and the sample size is large.
Yeah, I'm pretty sure that's correct as well, right? Because
I think there's only one that's incorrect, isn't it? Let's see.
Yeah.
Yeah, I think. Yeah, I'm pretty sure like the last one is correct, and it's just the third one that's incorrect, where the data is from a population that's right skewed, and the sample is small. Because
in that situation, you technically could get a normal one, but you could also get a right skewed one.
Yep.
Yeah, so I feel pretty comfortable with that, and that pretty much like gives you the answer to those 3 questions that we did at the beginning.
Yeah. Right.
So that's kind of ironic.
That's taking skills right there. Using the other questions to answer the previous ones.
Yeah. So in my accounting class, one of the textbooks they made us get was just this book about like test taking strategies and stuff, and it was written by this college professor where he talks about like how professors write tests and just like how professors usually like write questions. It was actually really interesting. Just to like go through that. But anyways.
Let's see. The best explanation of the central limit theorem.
I'm pretty sure it's the last one.
closer to the population.
Sample
Sample.
means. I think you're right. Because I think, I don't know, the first option kind of like almost had me, but.
Yeah, so in the book it says the central limit theorem states that if the sample size is large, then the bar X will be approximately normal.
Okay.
Let's see.
Which the bar X is the distribution of sample means, right? Because the third one is the definition of the law of large numbers. I'm just looking here in the book because it says that the law of large numbers states that the sample mean, which is the bar X, will be close to U, which is the actual mean.
Sample means is equal to population U. See, this is where let's see.
Does that sound good to you guys? Because that
The shade. I think it's the shade.
Yeah, because the third one is the definition of the law of large numbers, and then the second one is just the 68, 95, 99.7 rule. And the first one is just like one of the rules for how to know it's normally distributed.
Okay. Yeah, okay.
Because it's like it says right here in the book that the central limit theorem states that if the distribution of the sample means is large. Well, yeah, basically it's like exactly what it says there in the question. So pretty confident in that one.
Oh no.
What?
No, Bernard. Like I can follow through, but when it's thrown in front of me, I don't have my notes. Oh, I get a little lost.
Well, so like the population mean is 10, standard deviation is 6, and the sample size is 36. So what is the mean of the distribution of sample means? So the mean it lists as 10, so the mean of distribution of sample mean is going to be 10 as well.
Okay, that makes sense.
And then for 10.
Well, wait, do it. Maybe I'm. Doesn't that only happen when it's normally distributed though?
Yeah, but I guess I'm assuming that 36 is a big enough population size for it to still be considered normally distributed.
Okay. I was like, I feel like they either needed that or us to assume that 36 is big enough. Standard deviation, distribution of sample means. So again, that's where we take the standard deviation divided by the square root of the sample size, right?
Yeah.
Comes out to 1.
I got 1.
6. Yeah, and 6 divided by 6.
Oh yeah.
Oh, that's so funny. Look at question 11. Regardless of the distribution of the population, if the sample size is large, larger than 30, so I guess 36 counts. That would be normal.
Yeah.
On 11. What theorem that's isn't that the central limit?
Yeah, I think so.
Okay.
Because it's saying that if the sample
If it's
size is
large
large, then it's
Yeah.
it's the
Central limit theory with them? Okay. Yeah, because it said shape and not mean in the question.
I'm gonna go ahead and submit and see what I get.
I got
We got them all right.
14 out of 14. Woo!
Well done. Well done.
Well done.
Yeah.
Okay.
Good show.
All right.
Cool beans.
We
And so
meet
then I
again.
go to the discussion board, right, after we're done, and then post the link, right? That's all I need to do.
Mhm.
And just
Yeah,
list the attendees, I think, also.
Oh, right. Thank you.
Awesome. Good group, guys.
Yeah,
All right. Thank
nice
you guys
work.
for the explanations and everything.
Yeah, I appreciate the help and talking through and hearing your guys' thoughts. It's good.
All right, guys. Well, I think we're good. See if you have any questions.
Stay healthy.
What was that?
Stay healthy. Get better soon.
Yeah.
Yeah, I hope you feel better,
I
man.
know. Yeah. It's and the lame thing is like it's not like I'm sick enough to like lay in bed all day. It's just the sick where it's just like annoying, where like my throat's scratchy and my nose is a little bit runny and like it's I mean being sick is annoying regardless, but it's
Nope.
not like put you in bed for a week sick. So, no. So all right, well, I think we're good to go.
Hey, Jesse, are you going to run Wednesday also?
Yeah.
Okay. Awesome.
Okay,
Sweet.
thanks, guys.
Yeah, thanks. We'll see you Wednesday.
Good night.
Night.